f of x equals to e to the power x. E is the number 2.718 and e to the power x. So when we put the value of x, we can get any output value. So the domain will have no restriction whatsoever. So x is a real number. Now in case of the range, so if you take a look at the picture, it becomes parallel to this line. If you zoom in, you will see it does not actually touch this line. It goes very near the line, near the x-axis, or the line y equal to 0. X-axis means the line y equal to 0, and that is known as the asymptote of that graph. So visually it looks like this. This is the asymptote, and the e to the power x barely touches that, and this line is y equals to 0, meaning the value of fx cannot be equal to this value. It has to be greater than this value. So in this case it would be greater than the asymptote, greater than 0. This is the range of e to the power x. The range is going to depend on the asymptote, and we're going to have f of x is greater than, not equal to, because it cannot be equal to the asymptote. It's a broken line. And in this particular case, the range is going to be f of x is greater than b. Now if you add a number, what happens? The asymptote keeps rising. Suppose you have y equals to 2 e to the power x plus 3. So what happens? The picture would be, this is the x-axis, so this would be the asymptote. Previously it was 0, the asymptote would be 3. So it's a good idea to know the sketching of exponential function if you want to find the range. So this is the asymptote, so it is going to be fx is greater than asymptote, so greater than 3. Sometimes the picture could be like this. It could be y equals to 3 e to the power minus x plus 2. Now in this case, if you take a look over here, again plus 2 means the asymptote is this 2. So y equals to 2 is the horizontal asymptote. This is where we are focusing. And e to the power minus x means reflection on the y-axis, so the picture would be like this, in this direction. Either way, the range is going to be fx, because the picture is above the asymptote, greater than 2. If the picture was below the asymptote, it would be fx less than the asymptote. Then when we have f of x is equals to ln x, ln is the natural logarithm, log base e. So the natural logarithm of 1 is 0. The natural logarithm of 2, we get a value. Then the natural logarithm of 3, we get a value. So we got 1, 2, 3. How about the natural logarithm of 0? So the natural logarithm of 0 is mathematical error. How about the natural logarithm of minus 1? That's also a mathematical error. That means when we are finding the input values, it cannot be 0 or below 0. It can only be positive values. So the domain is going to be x is greater than 0. So that's the domain. The range, the output value, once you set up the domain, the output value has no restriction. So the output value can be any particular real number. So the output value is going to be fx belongs to any real number. So if we have ax plus b, in case of the logarithmic function, what is not allowed is that it cannot be 0 or it cannot be negative. It can only be positive. That means ax plus b can only be greater than 0, only positive. So this turns out to be, if we solve the inequality, minus b by a. So the domain is going to be x is greater than minus b by a. If we have f of x is equals to ln twice x minus 4, that means twice x minus 4 can only be positive. It cannot be 0 or it cannot be negative. So the domain is going to be x is greater than 4 by 2. So x is greater than 2. Another example would be if we have twice ln x minus 1 plus 5. Now this 2, the coefficient, and this 5 added over here doesn't really involve the question. What we need here is what's with the logarithms x minus 1. So x minus 1 can only be positive. It cannot be 0, it cannot be negative. So therefore x is greater than 1. This is the domain of the log function.